Hello, this is Waka breaking it down, the video on 2011, number 5, AP Stats. This problem is all about linear regression and checking the test for slope. You'll see in number 5 that it's talking about windmills. We got electricity compared to the wind speed. So the wind speed is measured in miles per hour, and the electricity is amperes. So just getting our units laid down. I can also see in the prompt that they're telling me what their domain of their x values were, so that when you make predictions, you'll know whether you're extrapolating or not. So that's the information I'm kind of getting from this. What's the input? What's the output? And they also give me the domain. In the computer readout, I see things that I'm going to need r squared. We do not use the adjusted. That's for multiple regressions, which we're not doing. And in this particular problem, we're going to need these two numbers, the y-intercept and the slope. And we're also going to use the p-value of the slope. We don't need the other numbers. So none of these other numbers I really need for this problem. Okay, but we'll go through them one by one. All right, so part A, use the computer printout to determine the equation of least squares line. Okay, so the one with the constant, the number right across from the constant, that coefficient is the y-intercept. And then the number next to the explanatory variable, this is always the explanatory variable, is 0.24. So that's the slope. All right, so I'm going to go straight to the answer on this one so you can see it. I'm just directly using those two numbers and these and the names, right? The wind velocity and the amperes. So here we go. You'll notice they use the word predicted instead of putting a hat on there. You can do one or the other. I like the hat, and then you don't need to write the word predicted. That's more common. So that's what I would do, and just put the variables right in there. If you use x and y, you have to define those on the side separately, so it's easier just to write them in. All right, you can see how we set the slope, 0.24 is there, and the y-intercept is there, and that's it. That's your equation, okay? So nothing mysterious about any of these questions on this one. Pretty straightforward. Part B, how much more electricity would the windmill be expected to produce on a day with 25 miles per hour versus 15 miles per hour? So we're just going to make a prediction using the equation we already have. I like to just double check real quick to make sure that 15 and 25 are within my domain. I have to make sure that I'm not extrapolating, and that's the reason they gave you these two values to start with, right? They want you to know as well, okay, because if they didn't say anything, you'd be like, well, I don't know if I'm supposed to do a prediction on these or not. I don't know if they're extrapolating or not. So they have to tell you that, give you a little information. So here we go. You got the slope, right? Um, you can did they even do, they didn't even do the actual calculations. I would have calculated both values and just compared them, just thrown them in the equation. Um, but they just talk about the slope. They're like, well, when you go from 15, 15 is less than what were the two numbers? Yeah, 15 and 25, right? So when you go from 15, 15 is less on the x-axis than 25 is, and we know that this has a positive slope, so it's going to be going up, right? So as the x value increases, the y values are going to increase as well. So for a bigger x, in this case 25 miles per hour, it's going to have a bigger wind speed than the 15 would, just because the slope tells me that we're increasing as we go along. So this is a difference of 10, right? So from 15 to 25. And if the slope tells us it increases by 0.24 for every single mile per hour, I could multiply that by 10. Like you can see that that's what they did here. Sorry. And we will have 2.4 amperes higher on a 25 mile per hour wind velocity day than the 15. You'd get the same answer if you actually just put in 25 and you put in 15 into your equation, get the two values. You'll see that when you subtract the two, you'll get 2.4 anyway. So it should be the difference, no matter how you did it. All right, part C, what proportion of the variation? Okay, so as soon as they say proportion of variation, I know we're talking about r squared. That's the coefficient of determination. And you just have to explain that. So I'm 87.3%, sorry, 87.3% of the variation in electrical production in amperes can be explained by, they almost tell you right here how to say it, can be explained by the relationship with the wind velocity. So yeah, I like how they almost tell you how to say it right there. Part C, so this is the proportion of variation in electrical production, right? That can be explained by the relationship or the association with the wind speed, right? That's your 0.873. You just have to identify that. So 87.3% of the variation. These are just direct explain, right? Plug and chug maybe a little, or explaining. The B is understanding slope, C is understanding coefficient of determination, A, how to figure out your computer printout, right? Okay, part D, this is the testing part, and for Unit 6 we haven't really done this, but Unit 7 you're definitely doing this. Sorry. Is there convincing evidence that we have the electrical production is related to wind velocity? So that's a direct test. Normally, when we're checking association, we just look for the slope, and we want to say, is there a slope that's either positive or negative? In other words, is there association? If we had a slope that was zero, like if this slope was zero or close to zero, then we might be thinking that there is no association between the two. But in this case, we have a positive slope. And when we do the test for this, the null hypothesis is almost always going to be zero. So we're saying, oh, we're looking to see if the slope, which we always use a capital B for the true slope, capital B1, is that equal to zero or not? So that would be my null. And then the hypothesis would be, is it, greater than that? So we're just trying to disprove that. So when they did the test against that, which this number is always telling you the results of the test, and you have a t-score here too, by the way. So the t-score is very high, 12.6. Gives us a p-value very, very low, like almost zero. So the p is low, reject the whole, right? So the p is almost zero, so we reject the null hypothesis that there is no association in favor of the alternative hypothesis that there is an association going on. In this case, a positive association. So I would just talk about the p, saying how that's really close to zero, less than 5%. We reject the null of zero, and we have evidence to suggest there is an association. So hopefully that's what you see here, right? They go ahead and they get their null and their alternative written out. They quote the t-value as well as the p-value being very low and less than 5%. And then they talk about how we have very strong evidence that there's a linear association with wind speed. Okay, and that's it. That's it's easy, but there's pieces you have to have, right? You have to have your null and alternative. Talk about the t and the p. You could probably get away without mentioning the t, but definitely need the p for sure. And then what the result is, right? Reject the null and support the alternative. By the way, never support the null, right? We don't always, even if we reject the null, we don't have evidence to say it's wrong. It could still be right. There's a 5% chance that it's still correct, right? Or some kind of a chance that it's still correct. So we never like totally disprove it. So just talk about the alternative. That's my point. You can reject or fail to reject the null and then talk about the alternative. We're talking about this and saying there is an association or not. Do we support that alternative or not? Okay, that's it for this walk off breaking it down video. Happy studying.